Group. We'll give everybody a chance to reset here just a second. But I want to welcome our next keynote speaker. Like I say, Michael Peeters is going to have a tough following act, but he is up to the case and up to the charge. We really appreciate having him here. So I want to introduce our next keynote speaker, Michael Peeters, who serves as the Chief Technology Officer of Alcatel-Lucent's wireless division. Now I'm pleased to welcome him as our keynote speaker. And prior to his current role, Michael served as CTO for Alcatel-Lucent's wireline division, where he helped shape the company's future by spotting new trends and technology. And today, Michael serves on several industry-shaping boards, including 4G America's Board of Governors, IEEE, Photonic Board, and ADIS, the Executive Board standard-setting body. His research is also widely published, and he holds patents in the access and photonics domains. Wow, impressive. Okay, everybody come on in, because I want to introduce Michael Peeters. Michael Peeters, let's clap for Michael. Thank you.
Thank you. You've Googled me, I see. I appreciate that. So, as they say, for something completely different, although I appreciated the comment that Rodney made with respect to where do we go and where do we need to invest for the next 5 years, and what about 5G. So, infrastructure vendor keynotes at carrier events are an interesting beast. I mean, they fall essentially into three categories. Either I will do a thinly veiled pitch about product or corporate, of which we have been guilty, or I will tell you how you should run your business so that we can sell more gear. We've been guilty of that as well. Or you have a third kind, which tries to give you some strategic perspective and has you walking out with a new framework. So I will try to do the third thing, and don't hesitate to throw something at me if I tend to digress into the first two. It's a perfect time to talk about the future. I mean, Mobile World Congress, as some of the previous speakers have said, is just past. And there was a lot of hype, which I don't like, because people tend to blow up things they don't have yet, or present things they have as the next big thing, without really understanding where the industry is going. And if you look at the big topics at Mobile World Congress, there were a few big bubbles. First one was obviously 5G. Everybody's talking about the next big thing. Nobody knows what it is. Second thing is related to 5G, a lot of talk of network function virtualization. I'll go into that a little bit because I think it's important also for competitive carriers. Third big bubble is ultra broadband, big driving force. And there was some side discussion on fixed wireless local loop, where I think there's a bigger opportunity also for competitive carriers. And tied to that ultra broadband space, one of the biggest polarizing issues in Barcelona was, what do you do with LTE in unlicensed spectrum? What's going to happen with LTE-U? What's going to happen with Wi-Fi when LTE-U shows up? I'll talk a little bit about that. And then things I won't touch on are, of course, the launches of the new high-end devices. There's a few new competitors that are coming in, MediaTek, Intel, that have chipsets that are essentially positioning these chipsets as venues to go towards lower cost devices, so definitely of interest. I won't touch on those either. And of course, the Internet of Things. So if you came here for the Internet of Things to hear about GPS wireless enabled sneakers, or a watch with LTE in it, and frankly, that thing is huge. It's the size of a pizza. Or a pizza clicker to put on your fridge such that you can order pizza with a single touch, you will be sorely disappointed. What I would like to talk to you about is what do all of these things mean from a perspective of the situation you're in today? And just to frame it a little bit, if I look at the state of the art for you today, it's essentially, one, what do I do with my devices? And in the last 6 months, a lot of that has been solved, also thanks to the input of the CCA. Second, if I transform to LTE and an IP core, What's the cost of that infrastructure? What expertise do I need? And is that expertise, in fact, the one I need for the next few years? And thirdly, what about spectrum? Is there going to be new spectrum? What does this 5G thing mean? What spectrum is it going to use? And so on. But the key message, I'll give it to you up front, is that with the evolutions from a technology perspective we see in the next 5 years, partnering is going to continue to be as important or even more important than it has been in the past. So, what is the framework I would like to share with you? The key element is a divergence is coming. And you can plot this using exact numbers. Then the graph looks a little bit less clean, so I'll do it stylized. Vertical axis is the amount of traffic per subscriber per month. Essentially driving your cost, how much spectrum do I need? Horizontal axis is more or less telling you something about the number of subscribers. And these can be humans, but in general, looking towards the future, they could be machines, they could be agricultural drones, they could be a variety of things. And if we look at the 2G area, the business case scaling was more or less easy because the traffic scaled proportional to the number of users. And as we moved to 3G, that curve started to go up a little bit because the mobile broadband per subscriber was increasing, but it was still more or less limited by the technologies that you had in place. And where we are today, of course, is the era of mobile entertainment. And the total traffic, if you look at the curves, in fact, the subscriber numbers are saturating, but the total traffic numbers continue to go up. Which means that you're now driven by the average data usage instead of the number of subscribers. And going back to the AWS-3 spectrum auction result, that's exactly what's happening. If you plot that out, you realize you need more spectrum as quickly as you can, because otherwise you're going to hit that asymptote. Where are we going now? Is that continue to go up? Yes. Likely mobile broadband will continue to go up, but there is a possibility that we will start hitting other asymptotes. So we're going up, 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 which means in the black and white world, it's a single subscriber eating all of the bandwidth in a single cell. But at the same time, there's a second asymptote that might be coming with the machine-to-machine Internet of Things, which is an infinity of devices eating all of the control plane capacity, but not actually generating any measurable traffic. Which is why the industry essentially has a driving vision of this new unified network. And it should have the traditional use cases as well as new use cases. And I'd like to focus on the first one here, mainly because in 20 minutes there's only so many things you can touch on. But there is a first use case that's going to continue to be drastically important, which is ultra broadband. And this is this first asymptote. And that's essentially the evolution of the communications entertainment network. And so it's human to human, human to machine, uploads of videos, photos, and so on, and machine to human mobile entertainment. But you should never lose sight of the fact that there will be a need for an investment in maybe ultra narrowband isn't the right word, but for want of a better word, ultra narrowband, where machine to machine is going to hit your network. Those two things together mean you will need a very highly flexible network. But let's focus on the first one, ultra broadband. The way we look at the next 5 years, in fact, for the broadband case, there's a limited amount of uncertainty. You have, and I'm being honest here, I could have left Wi-Fi out and just say LTE is everything, but that's not true. So Wi-Fi will continue to evolve. We'll go to AC, we'll go to AD, there's AX is in preparation. And the LTE will also continue to evolve. So that's the first important message. It is very hard to define a new network or a new technology that will do better than LTE from a spectral efficiency perspective. So the ultra broadband case will continue to be served by LTE and LTE Advanced and so on. But what will happen is that at a certain moment in time, as the 5G standards start converging, early 2019, you will get networks that essentially tie the three together in a way more seamless fashion. And this ties into this partnering aspect. Even when you have a 5G network, you will still need the LTE networks, be it local, be it global, you will still need Wi-Fi, and you will tie the three together to offer a single pipe. You'll have devices that offer a single pipe to your end user. The trigger for 5G right now, as far as we can tell, is mainly driven by marketing. There's a few big operators that want 5G for their next big thing because they have Olympics or they have some football game. And then at a later stage, probably latency, augmented reality will come up. The real big new things like millimeter wave are far out in the future. Spectrum from that won't be available until 2019 at least, and probably building those things at cost with a limited number of complexity is going to be hard. So the millimeter wave will happen, but that's for us a second step. To be prepared for that evolution track, there's an architectural shift that we think is necessary. And this is not 5G. I don't even call it 4.5G because that doesn't mean anything to the end user. It's an architectural shift to two things. One, virtualization, and two, small cells. And what is driving this architectural shift is that combination that we will need in the next years to efficiently tie together all of those networks. And it's driven by essentially three big drivers. One, you need to improve your network performance because the user demand is going to be there. Second, you need to improve your profitability by sharing and reducing costs. And especially that sharing of cost is important in the framework of the CCA Association, is what can you do with your architecture to actually make sure that you don't need to have a scale of millions and millions and millions of users to benefit from new technologies. And thirdly, you would like to differentiate in your local markets. That coupled with a number of resource uncertainties and traffic uncertainties. I mean, you can predict broadband, but all of those new traffic types coming up drives a new architecture that has flexibility for new demand patterns, better quality of experience, better total cost of ownership, less equipment at the cell site, less time for truck rolls, and enables that smooth evolution so that when 5G networks happen, either driven by one of the bigger players in your association or by a partnership, that you can actually evolve to it without requiring yet another huge capex round. From our perspective, and this was one of the big trends, not just for Alcatel-Lucent, but for some of our competitors at Mobile World Congress as well, it's all about virtualization. Because virtualization, in fact, enables that scalability. And going a little bit, putting my technical hat on, if you think about a vRAN, what that would mean and how that would look, what you need to think about when you think about a virtual radio access network is applications abstracted from hardware. And we see three big blocks in what a vRAN could look like. The first one is the virtual BBU. So our eNode B, the base station, what you use to essentially serve your users. We're virtualizing that such that when we shift to new features, to 5G, whenever it will be there, that could be a software upgrade that you do in some data center that is hosted either for a single carrier or maybe you're sharing that data center with multiple carriers. Secondly, there's a lot of RAN coordination and local applications that you could host there that could be specific to a region. If you have that data center, you would host it at the same place. Content delivery networks, local breakout, enterprise services, and so on. And that virtualization will then allow you to have a continuous cost performance benefit and flexible capacity. You only install what you need, and as users come in, you just add GPP blades. That only solves, however, one part of the equation. It just takes care of the operational side of things. You still need more capacity. So solving the capacity problem is the other thing that everybody was talking about at Mobile World Congress, but more on the sideline because of the fact that it's actually taking off in many markets already, which is small cells and Wi-Fi. And actually, I think of small cells and Wi-Fi as a triangle that altogether help to increase capacity. And there's three big things that impacted the Wi-Fi small cell space at Mobile World Congress. First one was, how do you deploy small cells more efficiently? Second, what can you do with unlicensed spectrum, and should you do LTE with unlicensed spectrum? And thirdly, is there something that you can do that actually sits on the intersection between Wi-Fi and LTE? And I'll touch on each of these shortly. So, number one, what do you do with small cells? Well, the number one innovation necessary is how do you deploy them efficiently? And a number of players in the industry, both ourselves and again, some of the other infrastructure vendors have realized that this is a problem, and they've started to do partnerships with local regional players that own, for example, street furniture. Street furniture that you could then use to host your small cells, single operator, multi-operator, add in Wi-Fi connectivity, have the external antennas, and this is in fact a real picture of such a deployment. You can even insert your microwave backhaul if you will choose to do so, but L-Fiber and other connectivities are available as well. Now, so then you have your small cell, you have your LTE, you have your Wi-Fi access point. What more can you do? Well, if you look at the wireless network today, especially in unlicensed spectrum, there's been a lot of polarization. And the polarization between using LTE in unlicensed spectrum or using Wi-Fi is in fact at the end of the day irrelevant. It's a bit like the debate between voice over Wi-Fi or voice over LTE. Your customer doesn't care. The same should be for LTE and Wi-Fi and the polarization. The customer doesn't care. It's noise. So if you look at unifying Wi-Fi and LTE, there's two ways to look at it. First one is, what can we do with Wi-Fi or unlicensed spectrum to boost the cellular? And the second one is, what can we do with Wi-Fi to actually boost it by using cellular? And so it's exactly the opposite. One is unlicensed for cellular, the other is Wi-Fi for licensed. And those two things are something to keep in mind when you think about where to migrate to, especially since Wi-Fi will be an integral part of a 5G network. It's not going to disappear either. And so the cellular boost is in fact LTE. You add spectrum either using LAA, which is the standardized version that will be ready sometime next year, or by using the LTE forum specs to your existing LTE as another carrier aggregated carrier. And of course, this is not just for 2.4 and 5 gigahertz. A lot of the industry is also looking at making this work in 3.5 gigahertz once that becomes available in the US. But that's going to take some time. So on the other hand, there's something you could do by coupling Wi-Fi and cellular that doesn't require new standards. So you could boost Wi-Fi. And again, just putting on my technical hat for a few seconds, the way this works in a nutshell is if you have a Wi-Fi deployment or a partner that has a Wi-Fi deployment, you'll notice that it has a huge advantage over cellular. It has huge amounts of downlink bandwidth. Unfortunately, it's constrained in range and in throughput by the uplink. On the other hand, you have an LTE network or even a 3G network. This one is not constrained by the uplink because it's very tightly scheduled. It's constrained by the amount of downlink bandwidth you can offer for streaming services, video, downloads, apps, and so on. So if you combine the two, and what we've done in fact is you send the downlink over Wi-Fi, you send the uplink over LTE, which is something that can be done with a handset upgrade. You can actually boost your Wi-Fi throughput and boost the range of the Wi-Fi network, at the same time reducing the load on your LTE network. That's the first step. Second step that's happening in standardization is in fact LTE Wi-Fi aggregation, which is adding Wi-Fi as a supplemental carrier to LTE, again without requiring a change or a regulatory impact because of the fact you're using LTE in unlicensed spectrum. And I think those two are important things to keep in mind because they maximize your user experience by actually using multiple technologies, and that will be necessary and continue to be necessary in the future. So, big things, 5G. The evolution to 5G will require multiple networks. LTE will remain in place. Wi-Fi will remain in place. And finding the right partnerships in an ecosystem that combines multiple accesses to different technologies is going to be key to be competitive. And so the universal takeaways that I have, and this is for any carrier, is one, broadband continues to grow, and you will need the flexibility and scalability up and down to address the capacity. Second, the more you move into cloud, the more you virtualize, and the sooner you do it, the more flexibility you'll have to partner and to add on and shift to new technologies. And thirdly, well, 5G is on the horizon, but just make sure your architecture is ready and don't worry too much about all the hype about the technology today. And all of these three things, if you execute them correctly, you'll be ready to also tackle the opportunity coming from machine to machine and the Internet of Things, which will require that flexibility and that scalability as well. And I hope, especially for that last one, which I couldn't cover in 20 minutes, I'll be able to talk to some of you at the remainder of the show. Thank you.